Hello everyone. Today is the lecture 3 of unit 3 of real analysis. We are seeing about the topic limit, and last class we have seen that what is the definition of the limit. Whenever I say that limit x tends to a fx is equal to L, that means that for every epsilon, for a given epsilon, there exists a delta positive such that fx belongs to that L minus epsilon to L plus epsilon whenever x belongs to a minus delta to a plus delta minus a. That at a the function may or may not be defined. Okay, so this is the epsilon delta definition. मैं पूरा last class से बुझे तो for a given epsilon, right, we have to suit this L minus epsilon or L plus epsilon. For these epsilon, there existed delta of the point A neighborhood, delta neighborhood, such that whenever the point is near, fx lies in this interval, right? Okay, so we say that fx has limit L whenever x tends to a, and that a must be the limit point of the function. Means a must belongs to the dx. D is the domain of the function and dx is the derived set. So a must be in the limit point. A must be the limit point of the domain. Okay, next we will see that some examples in the sense, suppose mote koha gala so that limit x tends to 2, fx is equal to 4, where fx is nothing but x square minus 4 by x minus 2 whenever x is not equal to 2. Okay, आमे ये सब number class 12th 11th रे बहुत बढ़िया कर existence of limit or how to find the limit. But now using the epsilon delta definition, how we can show that the limit extends to 2 fx is equal to 4. तो very clear आमे very clear थिबार कथा आमको गुडे epsilon दे दिया हबा ता लगे आमे delta रे भाग करमु. That's all. What is that fx? What is that L here? L is nothing but 4 here. A is nothing but 2. Need to find मोते देखावा छे the distance between fx and L. L it is nothing but 4 here is less than epsilon whenever 0 is less than mod of x minus 2 is less than delta. Whenever writing 0 is less than or less than, because strictly less than is in the sense because x is not equal to 2, because x may or may not be आमे जमते define कहितले मुई function रो limit केबे बाहर करा ऐसे गुटे point से point रे function define नहीं भी थे पारे हे भी पारे नहीं भी पारे. तो better, that's why we are always deleting the point where we are finding the limit. So here 0 is strictly less than x minus 2 is less than delta. So my aim is to find what is that delta. So first of all we find what is that fx minus 4. So for x not equal to 2, fx minus 4 is equal to what is that fx we have? X square minus 4 by x minus 2 minus 4, factorizing above that x minus 2 into x plus 2 by x minus 2 minus 4. Since x is not over 2, so x minus 2 is not equal to 0, I can cancel it. Make sure that whenever we cancelling this x minus 2 with x minus 2, it must be not equal to 0. Since x is not equal to 2, so I can cancel this one. So solving this one we get x minus 2. So my aim is to show that fx minus 4 is less than epsilon whenever x minus 2 is less than delta. So I will observe kari parma fx minus 4 is nothing but x minus 2 bhari che. So I can choose our delta. Choose delta is equal to epsilon नहीं parma. क्या लगे देखो whenever एवं में जो देखो मैं whenever x minus 2 is less than delta. Delta is nothing but my epsilon. So I can say that fx minus 4 is less than, this is nothing but x minus 2. Here it's less than epsilon कोई parma के नहीं. So whenever x minus 2 is less than delta, fx minus 4 is less than epsilon. Hence I can say that by definition of limit, I can say that limit x tends to 2 fx is equal to 4. Okay, so the thing is that सबुल आमको गोटे एप्सिलॉन टे देथिबा ताला गोटे डेल्टा टे बाहर करा आसी आ गोटे इंटरेस्टिंग एग्जांपल so that limit x tends to 0 fx is equal to 0 where fx is nothing but root over of x is greater than equal to 0. The domain is x greater than equal to 0. Again same thing here. What's that fx here? Is root over of x. What's that L here? 0. A is also 0. So my aim is to show that fx minus L is there 0 is less than epsilon whenever 0 is less than strictly less than x minus 0 is less than delta. So my aim is to find what is that delta for a given epsilon. So now what is that fx minus 0? I am a bhar karma fx minus 0. Is it fx? Is nothing but root over of x minus 0. That is nothing but root over of x because root over of x is always positive. That must be less than epsilon. Correct? Whenever x minus 0 is less than delta. So I am observe kari parma choosing delta is nothing but what? Epsilon square, because x is less than epsilon square. So hence I can say that whenever x minus 0 is less than delta is nothing but my epsilon square, fx minus 0, it is root over of x is less than root over of x is less than epsilon square. So root over of x is less than what? The epsilon is. Hence I can say that limit x tends to 0 fx is equal to 0. But ebe gote kotha koime me sobu jinis re, these are the examples where we have given with L and just we are showing that limit existence. So amar pakhe fx oche L oche points oche sobu oche. Now the thing is very clear, when we are not given with the L, just we have given with the function fx and the point x tends to a. In that case, what about the existence? If it exists or not existence? If it existence, where it goes to? Now say kotha rahla L सबुबले non जदि non देथिले से केस रे आमे केंदा जन्मा की existence है कि limit exist ना करवार. For that reason, there is an important theorem. That's just I am writing that theorem. So the theorem is called a sequential criterion. That is very nice approach for the existence of limit. What it says that let D be the subset of R. F is a function from D to R. D is generally we are taking the domain of to the real number. Be a function. Let C be a point, limit point of D. That means C belongs to D dax. And L belongs to R. We have a point where the limit goes. Then limit extends to C fx is equal to L. If and only for every sequence xn in D minus C converging to C, the image sequence f of xn converges to L. So first of all, हमें theorem रो statement के बुझू हमें was that theorem says about. So suppose this is my image line, fx line और image line को हम हमें, and we have the point line or domain line. Okay, so we have a point C and we have to target that L again. So हमें कहमा C point रे limit exist करबा केबे जदि मोर पाके गुटे सीक्वेंस अच्छे जेन सीक्वेंस ता कहा के कन्वर्ट करू छे C के. Okay, we have a sequence in D converging to C. Then the image sequence, suppose this is x1, suppose this is x1, x2, x3, x4 converging to C. Then the image sequence f of x1, f of x2, f of xn कहाँ के कन्वर्ट करवार कथा L के. आओ थोड़े. So whenever there is a sequence xn converging to C, at the same time the image sequence must converges to the L. ओके जदि लिमिट एक्जिस्ट करूछे ताहेले मीन्स आमको एक उल्टा कथा देखवा छे ई जिनिसटा हला जदि जेबे xn converges to c f of xn converges to l अच्छे then I can say that limit at c exists and that is equal to l. Now उल्टा कथा if and only जेहेतु हमको देई छे the thing is that जदि लिमिट एक्जिस्ट करूछे c रे तार मीनिंग जदि गुटे सीक्वेंस xn c के कन्वर्ज करूछे तार इमेज सीक्वेंस कहा के कन्वर्ज करवा l के ओके तार यूज टा करा हमें नेक्स्ट वीडियो रे देखमा बट नाउ वी विल प्रूव दिस स्टेटमेंट दिस थ्योरम ओके एंड इतार यूज टा बहुत beneficial for the non-existence of limit and we'll discuss in the next lecture. Now today in this lecture we will see the proof of this theorem. Okay, so first of all we will prove the necessary part. Prove necessary part. Let limit x tends to c fx is equal to l. That means the limit of the function at x equal to c exists. Now mote proof karan kora chhe if we have a sequence if xn is a sequence in d minus c then such that xn converge karuche kaha ke c ke mote proof korba chhe what's my claim I have to prove that the image sequence f of xn also converges to the point L. So we have given that limit exists and we have a sequence xn converging to C. Now I need to prove that the image sequence converges to L. So we'll start one. Given limit x tends to C fx exists means limit exists koruche. That means for all epsilon greater than 0 there existed delta positive such that fx lies between L minus epsilon ru L plus epsilon. Fx belongs to L minus epsilon ru L plus epsilon whenever x belongs to C minus delta to C plus delta minus C deleted neighborhood of C minus delta. Deleted delta neighborhood of C. This is our given for the limit existence. Now again we have that xn converges to C. Again we have a sequence xn converges to C. That means what? For delta, what we have that delta delta bhari che. For delta positive there exists a natural number m belongs to n such that after the mth term the convergence of the limit sequence, so after the mth term all the terms lies in the delta neighborhood of C. After the mth term all the terms of the sequence lies in this neighborhood, okay, such that xn belongs to C minus delta to C plus delta after the mth term. After the mth term all the terms lies in this. Now from this data whenever x belongs to C minus delta to C plus delta that image point fx kahar madhye raho chhe L minus epsilon or L plus epsilon. Now we have a point xn in C minus delta to C plus delta implies f of xn belongs to where L minus epsilon to L plus epsilon after the mth step. That says that the sequence f of xn converges to L. So we have shown that if we have the limit existence and we have a sequence xn convergence to C, then the image sequence converges to L. Now we go for the sufficient part, and that is very important and interesting. Sufficient part. What we have given with whenever xn is a sequence in D minus C and xn converges to C, we have that f of xn converges to L. The image sequence converges to the point L. My claim is to show that limit x tends to c fx is equal to L. I need to prove that the existence of the limit. Okay, so as in the first lecture we have seen that what do you mean non-existence of limit. Non-existence of limit, again I am repeating, just 1 minute, I am just repeating. Suppose L, we have the point C and say that fx ର limit x tends to c ରେ exist ନାଇଁ करबार. ता मीनिंग करा देखो आमे का कोदला for all every epsilon there exists a delta, for every epsilon ର negation करावा there exists a delta. सामना लोकटा मते एमती चैलेंज टा देला गुटे एमती नेबरहुड देला L minus epsilon ru L plus epsilon ता लगी केनसी भी c रो नेबरहुड नेले चेन भी c रो नेबरहुड नेले ता सबु पॉइंट रो इमेज इ भितरे लाए न करू थाई न करे. So there exists an epsilon neighborhood of L for which no delta works. Means whenever you take whatever the neighborhood of C, whatever every delta, for every delta, whatever you take the delta neighborhood of C, the image of every point in this interval not lies in this interval. Means it may happen that some of the point whose image lies in this, but not every. Means there exists a point in this interval whose image lies outside this one. Okay, so there exists a point in this neighborhood whose image lies outside the epsilon neighborhood of L. So we will prove this by method of contradiction. Let limit x tends to c fx does not exist. That means there exists an epsilon positive such that for all delta positive, for every there exists epsilon for all delta. Okay, there exists some point x belongs to c minus delta to c plus delta such that fx does not lies in the epsilon neighborhood of L. Okay, whatever you take the delta, there exists a point in this one, in this neighborhood whose image lies outside that L neighborhood, epsilon neighborhood of L. Okay, there exists a epsilon such that there for all delta, whatever you take the delta, there exists a point in this point neighborhood whose image lies outside this epsilon neighborhood. Okay, so first of all I am taking let delta is equal to 1. I am taking the delta equal to 1. So c minus 1, c plus 1, there exists a what a point x1 belongs to where? C minus delta to c plus delta such that f of x1 does not lies in L minus epsilon to L plus epsilon. Okay, for again for delta is equal to 1 by 2, there exists a point x2 in belongs to where? C minus delta to c plus delta such that f of x2 does not belongs to L minus epsilon to L plus epsilon. Similarly for delta equal to 1 by 3, there exists a x3 in belongs to c minus 1 by 3 लिखुचे हमें plus 1 by 3 such that f of x3 does not belongs to L minus epsilon to L plus epsilon. In this way we have a sequence. In this way we can develop a sequence xn such that f of xn does not belongs to L minus epsilon to L plus epsilon and xn टा किनो belong करूचेगा c minus 1 by n to c plus 1 by n. So we have a sequence xn in this such that f of xn does not belongs to this. That implies we can easily see that xn converges to c. because the distance between xn and c is less than 1 by n. So here xn converges to c, but f of xn does not converges to L because f of xn does not belongs to this interval. That means f of xn cannot converges to L. So we have a sequence such that converging to C, but the image sequence does not converges to L, which is a contradiction, since we have assumed that for every sequence xn converging to C, the image sequence converges to L, which is a contradiction. So our assumption is wrong. Assumption is wrong. And what we assume that key limit does not, that means limit x tends to C, fx is equal to L. Hence we have proven the theorem that is called the sequential criterion. Okay, thank you. In the next class we will see the usefulness of this theorem. Okay.